Okay, yeah. So, hi, good afternoon. My name is Daniel Mellado, and I've been working as a Kuryr PDL for this cycle. I'm also a Kuryr for that. And here's my colleague, former manager, Pino Candia, who currently works at Huawei as a, what's the title, Pino?
Cloud architect.
Okay, software architect. So I just want to first introduce you about what is Kuryr. Kuryr is a project we have been working on since the Liberty cycle, and basically it brings OpenStack networking to containers, and it acts as a bridge network in between OpenStack VMs and OpenShift/Kubernetes containers, so you are able to do mixed workloads in the infrastructure. So one of the features that we have been working in this cycle, usually we just go and translate Kubernetes objects to OpenStack. So we decide to do the same for the network policies in Kubernetes, which would map directly to OpenStack security groups. In order to do that, we decide to follow a similar approach to what we did for ports. So we probably will be creating a security group pool, because this would be running high in numbers. But we thought that this would be the closest match in order to enforce labels to the pods. So here's this Kubernetes spec. If you see there, you can have ingress, egress, and so forth from both IP blocks, CIDR, and so forth. And if you see the definition for a security group in OpenStack, it really matches a lot. So what we are doing here. So you want to go next, Pino?
So as Daniel explained, the point here is that Kubernetes networking should run on OpenStack Neutron, right? So that then we can enable any of the Neutron drivers, any of the Neutron-powered SDNs in a Kubernetes environment, right? So now, how do we get this network policy that you just saw, and I'll explain it in a little bit more detail in a second, how do we get it to run on OpenStack? Well, OpenStack's security primitive is the security group. Just to recap, you should, if you're not familiar with security groups are a membership set of ports. Okay, they're a membership set themselves, but they are also a set of rules for allowing traffic. Okay, so it's a whitelist of traffic. That's the second bullet here, and they can specify ingress, egress, IP address prefixes, destination protocols, and ports. And you can have many ports in a security group, and you can have many security groups apply to a single port. So this is very similar to the network policy. I'll show in a second how, but there are some differences. In fact, the last point is saying that this accept block in Kubernetes IP block is a little bit different. But otherwise, security groups look a lot like network policy. They're kind of like labels. They're a bit heavier weight to manage than labels, and we'll see that in a second. Over here in the middle, you see an example of how to create a security group. And so you can see there's a name, protocol, destination, port, and then some options. OK, so on the left, just so it's clear, that code on the left is the network policy that you saw a few minutes ago. OK, so that's how it looked before, just so you see it's the same thing. So on the top, this up here, can you see my mouse? This is what I'm calling the protected pods, okay? And the protected pods are matched by a label, the role databases. So we want to protect the databases. That's the point of this network policy. Before network policy existed in Kubernetes, it was assumed that everything was open and any pod could talk to any other pod, okay? When you drop a network policy in Kubernetes, then unless you specify the whitelisted traffic, everything is blocked, okay? So you go from everything open to everything closed. In this list, so over here, I'm just going to show you. So the ingress here means we want to specify ingress traffic. Because there's no egress in this, it means that egress is completely open. Okay? If I put egress and I put no rules, because it's a whitelist, that would block everything. So down here, we have three kinds of traffic that are being whitelisted. There's an IP block. Okay, that's pretty easy. But then we can also whitelist traffic from specific other pods. So these pods that are in the namespace, my project namespace, okay, thanks to the namespace selector, anything in the namespace, my project, can talk to the database pods. And finally, the pod selector here for front ends, anything that's labeled front end can talk to the database. Okay? So the question is, how do you map these concepts onto Neutron? And we do that with security groups, and we need a few security groups. One is the security group for the pods that are being protected. That's here. Okay? So Neutron translation, we create a security group for that. And then for all of these, the policy type, ingress or egress, will tell us the direction of the security group. Pretty straightforward. Any rule that we put in this security group, the protected security group, will depend on whether it's in the ingress or egress descriptions. And now the IP block, that's pretty easy. That just gets translated to IP prefixes. But since the IP block allows this accept, and Neutron doesn't have that power of expression of IP prefixes, then we might have to chop it up into smaller prefixes. Pretty straightforward. The namespace selector, there we need another security group to match any pod in that namespace. Okay? So we're going to start to juggle security groups and pods and match them. And similarly, this pod selector, for the front ends, another security group. These two security groups down here that are created, they'll be empty in terms of rules. They don't need rules. We're using them just as labels. So it's where we're using that kind of label-like property of security groups. And finally, at the end, any rule that we create, any ingress rule we create, will have this protocol and this port. One last detail that I wanted to give you is that these from blocks are, you could have multiple from blocks up here, right? And that might create other security groups and so on. And I'm not showing here the egress. It's similar for egress as well. And with that, I hand it back to Daniel.
So this is basically how do we think. We have several tools called watchers. So basically, a watcher is, as it implies, a watch that is listening for Kubernetes events. So we are watching where a pod is created, and when a pod is created, we are basically selecting its policy and then apply, as you see here. By default, we will create it up with a default security group. That would be empty. That would be equivalent to a label, as Pino was saying. But then, what we are doing is we are also annotating. In Kuryr, what we are doing, we are hosting all the Neutron information in terms of networking into the containers annotation field, and afterwards we will just be going there and create the annotation with the network policy. After all this is all done, we'll just be attaching the policy security group to the port, so it will get updated. Overall, this is how the workflow is going to be. If we go here, you can see, as Pino was reviewing and explaining, that basically we needed to map all the things in terms of Neutron, Kubernetes network policies to Neutron security groups, as we felt that it was the closest. And that's it in terms of this lightning session. So
maybe since we have a few more minutes, key takeaways then are that Kuryr allows you to run containers on Neutron networking, right? And this network policy feature, which Kubernetes added in its 1.7 version, okay, so it's been stable for a few versions. So we finally have security in Kubernetes, and you can have that using your Neutron SDN. And that means that if you're running VMs and containers in the same environment, you only need one SDN, thanks to Kuryr.
Yeah, so that basically allows you to avoid the double encapsulation that you would have with different SDNs, such as the OpenShift SDN or, the default ones that are shipping with Kubernetes. And on top of that, we do plan to ship this feature for Kuryr in this rocket cycle. So then,
questions?
Questions? Could you come over and so we can? We handle that with Kuryr. Kuryr is an OpenStack upstream project that basically we are using hooking into Neutron, and we get information from Neutron, and we have a CNI plugin. So we hook into Kubernetes via this CNI plugin. We were just we have a set of watchers that are watching for events, such as a pod is created, a pod is updated, we are creating a new service. So for instance, we started basically with Kubernetes objects such as services. So think about it, a service in Kubernetes it gets maps to a load balancer in OpenStack. So in our case, we map that to an Octavia load balancer. So using this exact same way, what we are doing is we are hosting, I mean, tomorrow we have a parent onboarding and we'll be showcasing this too, but we get all that information, hooking into the Neutron API, and we store that into the annotation field on the pod. Then it goes via its CNI plugin, and we just put whatever bridge, we hook up the pod, the port that is created by Neutron into the pod namespace.
Thanks for the question.
So,
any other questions? All right, well, thank you.
Yeah, thanks a lot.